What's going on, 8th grade math? How are we doing? It is the second week of our Google Classroom adventure. I'm already excited. You all are getting a lot of work done, and I'm really proud that you all are doing this, okay? But let's get to the notes. Our second week notes are going to be all about systems of equations. Like, what the heck are they? How do I even solve them? And then how can I solve it by graphing them? So, without further ado, let's get to the notes. Transition.
Grade. How are we doing? Today, we are going to be working on systems of equations, and this is something brand new, but I know that you all can do this. Today, I really need you to pay attention to the vocabulary, and I need us to remember how we can go about graphing, and that's what we're going to talk about. This whole video is going to be about solving systems of equations by graphing. So, the first thing, what even is a system of equations? Well, a system of equations is a set of two or more equations that use the same variables. So it could be like y equals 5x and y equals 3x plus 2, something like that, okay? A system of linear equations, notice the difference in the wording is linear. It's when the graph of each equation of a system is a line, okay? Of course, if they have linear, they're probably going to have line in there somewhere. And then the most important thing to remember out of this set of definitions is the solution to a system of linear equations. You cannot really see that well, so let's change that color. Let's do a light blue. Why not? So a solution to a system of linear equations is a set of values or for the variables that make all of the equations true. For many situations in a system of equations, it's just commonly going to be one point. One point of intersection is going to be the solution. However, if we look here at our next slide, there are different times where we have different sets of solutions or different number of solutions. So let's start with this first graph right here. This is commonly what we're going to see. Two lines that intersect at a certain point, and let's just make that point a different color. Why don't we go with red? It's going to intersect right there. The number of solutions is 1, and I would just have to state what that point is, okay? So the slopes are different, and the y-intercepts can be the same or different, okay? Same or different. Now, let's go with purple, okay? The second kind of solution is no solutions, okay? We can see right in here, if I were to highlight in here, there's no intersecting of these lines. There's a whole bunch of empty space here, okay? Which is why there are no solutions. They're not ever going to intersect. They're never going to cross each other. And we can see that in our definition here. The slopes are the same and the y-intercepts are different. So it could be, for example, let's change this color again back to black. It could be like y equals 5x and y equals 5x plus 2. I know that this system of equations is going to have no solutions because it has the same slope, but different y-intercepts, okay? And then this last one is when it's infinite, okay? An infinite slope, let's go with green, or a system of solutions that has an infinite number of solutions, we can see it's only one line, okay? Or it looks like one line. However, that doesn't mean that it's always going to just be one equation of a line. For it to be a system, there has to be more than one equation. So this is an infinite number of solutions because it all is on the same line. And we can see here that the slopes are the same and the y-intercepts are the same. So for example, I could go y equals 5x, and I could also have y equals 10 over 2x. These are two different equations, as in they're written differently. But if I were to simplify this, y equals 5x and y equals 10 over 2x, 10 over 2 is the same thing as 5. So their slope is the same, and their y-intercepts are the same. So therefore, they are going to be the same line. Okay? And let's just do one more remind. I'm sorry that this handwriting is not great, but slope-intercept form, because this is what's really going to help us when we are graphing. Slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. Let's just remember, when I'm trying to graph, I want to start with my y-intercept. I want to put a dot there first, and then I will use my slope to help me find different points on that line, okay? So let's put this into practice. Let's try to solve some systems of equations by graphing. So my first one, I have y equals x and y equals 2x plus 2. So I'm going to give these two different colors. So this first one is going to be in red. So if I see here y equals x, there is no y-intercept, which means that it's at 0. So I'm going to put a dot there. And then my slope is 1. Let's see if I can draw that in there. There we go. That means I go up 1 over 1. Up 1 over 1 every time. Okay, and you don't have to have this many, but you do need to have enough in order to have an intersection. So let's try to make a line here. Line style, not that. End. There we go. Start. Okay, so let's see here if I can do this. There we go. So that's going to be our first line. And let me change that line. Maybe. Doesn't look like I can. That's okay. So this second equation, I'm going to put this in green. So y equals 2x plus 2. So I need to go up 2 and put a dot right there. That is my y-intercept. Okay, so I know that my b equals 2 and my m equals 2 over 1. So now I go up 2 and to the right 1 every time for my slope. Up 2 to the right 1. Sorry, this is working kind of. I'm trying a new stylus out. That also means I need to go down 2 and to the left 1 if I'm trying to go the opposite way. So down 2 and to the left 1. And I can see that I have my intercept. So I'm just going to keep going, just that way it's a little bit easier for me to make my lines. So I'm going to draw my lines and let's see if I can change it to green. Okay, so let's go here. So I can see that that's going to be my line, and I can also see where my intersecting point is. I can see that I have an intersecting point right here at -1, -2, and down 1, 2, -2, -2. So the solution is one solution with the point being -2, -2. That means if I were to plug in each of these numbers in for x and for y, that this equation and this equation would come out with the same answer. Okay? But this is exactly how I try to solve a system of equations by graphing. I just need to graph each line and then find where they intersect. Nothing super terrible. Okay? Let's try another example. Y equals -2x plus 4 and y equals x minus 2. So I'm going to do this first one in blue. So for my blue one, I know that my m is -2, or my slope is -2, and my y-intercept is 4. So that means I need to go up 4 and put a dot there for my y-intercept. So I go up 1, 2, 3, 4. Make that look a little better for you. And now my slope is -2 over 1. So I go down 2 and to the right 1. 1, 2, 1. Here we go. 1, 2, 1. 2, 1. Sorry, this isn't going exactly perfectly, but that's all right. We're trying our best in this quarantine, aren't we all? I hope that everybody's doing okay. Please reach out to me if you need to talk or anything like that. I'm always happy to listen, trust me. So, there's my first line. And let's put this in blue. So, that is my graph of my first line. Okay? So let's pick a different color. Let's see, what colors do I have? Let's go like a peach, pinkish sort of deal. Is that easy to see? That's not too bad. So for my pinkish or peachish line, I know that my slope, I need to look in front of my x. Secretly, there's a 1 hiding right there. So I know that my slope is 1 over 1, up 1 and to the right 1. And I also know that my y-intercept is at -2. Okay? So that means I need to go down 2 and put a dot there. And now I need to go up 1 and to the right 1 every time. And I can already see where my point is going to be, or where my intersection is going to be. So let's try to graph my line here, that color. There we go. So I can see here where my intersecting point is going to be. It's going to be right here. So if I go to the right +2 and up 0, so that means my solution is going to be at the point 2, 0. And I can also go back to my previous definition on that chart or on that table. I see that I have different slopes and different y-intercepts. So automatically I know that there's going to be one solution somewhere. Okay? Hopefully we're doing okay so far. Let's go with one more example and then we're out of here. So y equals -3x plus 7 and -2y plus 6 equals -14. Now this is going to be a little bit different. So let's make this first equation red. So I know that for my red equation, my slope is 3 over 1 and my y-intercept is 7. So let's do that. 1, 2, 3, 4, 5, 6, 7. And my slope is up 3 to the right 1. 1, 2, 3, 1. So the other way is going down 3 into the left 1. 1, 2, 3. 1, 2, 3, 1. 1, 2, 3, 1. Sorry, you're going to hear a lot of me counting. But this is just how I go about doing this. 1, 2, 3, 1. Okay. So there's my line. That looks kind of funky. Up 3, 1. Up 3, 1. Up 1, 2, 3, 1. 1, 2, 3, 1. 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. Nope, that's right. Okay. Color, change that to be red. And then here we go. Perfect. Okay. However, this second equation is where I'm guessing some people are starting to freak out a little bit. I have -2y plus 6x equals -14. I already know that this equation is not written in slope-intercept form. So it's going to be very difficult for me to graph this. So what I need to do is I need to rewrite this so that way it's in slope-intercept form. So let's create another page and do that right now. So I have -2y, what was it, plus 6x equals -14. And remember, I need to get it into y equals mx plus b form. Okay, so I need to try to get y by itself. So what I'm going to do is first make this equal sign look more like an equal sign. Then I'm going to subtract both sides by 6x. Because remember, I'm trying to get y by itself. So I'm going to be left with -2y equals -6x minus 14. And since I'm just trying to solve for 1y, not -2y, I need to divide both sides and everything by -2. So I'm going to have y equals 3x plus 7. So that is the equivalent equation from this first part to the second part, okay? So these are the same, okay? But I'm going to use this equation written in slope-intercept form to help me graph just because it's a whole heck of a lot easier for me to graph with this. So I'm going to go back to my other slide and write that down. So y equals 3x plus 7. And I am going to use that to graph. So I go up 1, 2, 3, 4, 5, 6, 7. Up 3 to the right 1. And what would you know here? My equations are exactly the same, which in this case means that I have, as far as my solution goes, my solution is going to be infinite, or infinitely many. A little different on that last one, but that's okay. Most commonly, you're going to get it